In this video, we're going to be finishing up multiple angle and product to sum identities. So to start off with, we have half angle identities. With this, there are 4 different identities. The first one is sine of theta over 2, so that's what makes it a half because we're dividing it by 2. This equals the plus or minus to the square root of 1 minus cosine of theta over 2. With the cosine of theta over 2, we have plus or minus the square root of 1 plus cosine of theta over 2. And then there are a couple different ways for the tangent. I'm just going to give you the main meat of it, I guess, is going to be the square root of 1 minus cosine of theta over 1 plus cosine of theta. And sorry, that's a plus or minus as well. Okay, so you're going to have to use the half identities if you have an angle, if it doesn't add up to the 30, if it doesn't add up to say 30 or it doesn't add up to 45, you know, one of those angles that's on our unit circle, you might have to use a half identity and it'll be some angle that's actually on our unit circle. So for instance, sine of 22.5. Well, if I multiply that by 2, I get the sine of 45. So this is really sine of 45 over 2. Okay, so that 45, we can work with that. That's on our unit circle. So that's why we have those half identities. So I'm just going to go ahead and plug those in to my formula. It's 1 minus cosine then of 45 divided by 2. Now, technically, the plus or minus doesn't tell me that's my final answer. That just tells you, based on where you are in your quadrant, whether it should be a plus or a minus. Because it's a 45-degree angle and we're really at 22.5, that's going to be in the positive quadrant, so we know that that's going to be a plus. So I've got 1 minus, well, the cosine of 45 is the square root of 2 over 2. And that's all divided by 2. So to help get rid of my fraction, well, the square root of 2 fraction, I'm going to multiply everything by 2 so that I do no longer have that fraction. So I've got plus square root of 2, because 2 times 1 gives me the 2, minus the square root of 2 over 4. So again, I multiplied everything by that 2 so I could get rid of it. Remember that you can't have a denominator with a square root. The square root of 4 does happen to come out because the square root of 4 is just a regular 2. So this is my final answer, and that's using your half identity. You just kind of have to play around with that to figure out, you know, if you see a 0.5, you know that you're going to be doubling that to get a whole number in that case. Sometimes you'll be asked to solve equations using half identities. So for instance, if I had the 2 sine squared of x over 2 plus cosine x equals 1 plus sine x. So solve for x. I want to solve for x on the interval of 0 to 2 pi. So the first thing I'm going to do is I see that I have a x over 2, so that's going to tell me that I need to use that half identity. So I'm just going to rewrite that sine squared of x over 2 as 2 plus or minus, and I've got the square root of 1 minus cosine x over 2 And all of that is squared. Well, when I take the square, that gets rid of the square root. So I've got 2 times 1 minus cosine x over 2 plus cosine x equals 1 plus sine x. That also takes care of the plus or minus because whatever I'm squaring is going to be a positive anyway. Looking at this, I can then simplify the 2's because they cancel. And I've got 1 minus cosine x plus cosine x equals 1 plus sine x. I'm going to go ahead and combine like terms and try to get the x on the same side. So I've got 1 equals 1 plus sine x. Get the x by itself, so I've got 0 equals sine x. So I need to now use my unit circle and figure out where on my unit circle sine of x equals 0. And when I'm looking at my unit circle, x equals 0 or pi. So that's using, those half identities in order to solve for x. We have a couple more. We have product to sum identities and then sum to product identities. With this one, we have sine of alpha times sine of beta. So it's a product, and then it goes to a sum. Equals 1/2 cosine of alpha minus beta minus cosine alpha plus beta. If I have cosine alpha times cosine beta, that equals 1/2 cosine alpha minus cosine beta plus cosine alpha plus beta. Sometimes they'll be intermixed, and I'm just going to tell you it depends on which one's first. If you have a sine alpha, so if sine is first, that does make a difference on the formula. It's not the same formula for both of them. So we've got 1/2 of sine alpha plus beta plus sine alpha minus beta. Exact same thing. So if they're switched, so if it's cosine alpha, sine beta, it's going to be 1/2. And the thing that changes actually is in between. So I've got sine alpha plus beta minus sine alpha minus beta. Use an example here. We'll do one of these, and then I've got some other some product identities. We will not do an example with that one, so I'm sorry. It's just because of time. So if we have cosine 6x, cosine 3x. So I'm going to go ahead and use that cosine alpha times cosine beta. And I have 1/2 cosine 6x minus 3x plus, sorry, don't know what just happened, plus cosine 6x plus 3x. So I'm going to go ahead and combine like terms. So I have cosine of 3x plus cosine of 9x. Now, you cannot add these together. Even though, yes, the 3x and 9x are like terms, you cannot add them together because there's a function in front of it with the cosine. So you actually, the only thing that you can do is actually distribute the 1/2. So you have 1/2 cosine of 3x plus 1/2 cosine of 9x. And this right here is your final answer. Again, you can't combine those because the 3x and the 9x, yes, they're the same like terms, but they have the cosine with them. And the last identity formulas, and this is the last of the chapter, sum to product identities. And with this, we have sine alpha plus sine beta is going to equal 2 sine alpha minus beta over 2. Sorry, that's a plus. Cosine alpha minus beta over 2. And then for subtracting, so we have sine alpha minus sine of beta. That's going to be 2 cosine of alpha plus beta over 2 times sine alpha minus beta over 2. Now, again, order does matter, so make sure you know order does matter, whether you're adding or subtracting. So if I have cosine, if I'm adding 2 cosines together, I've got 2 cosine alpha plus beta over 2, and then cosine alpha minus beta over 2. And then last but not least, if I've got cosine alpha minus cosine beta, that's going to give me 2 sine alpha plus beta over 2 times sine alpha minus beta over 2. So this is the final identities that you will be given. Again, I will go through an example in class. I'm sorry that there wasn't enough time to get through using any of these.